Hi friends, good evening. I am Dr. J. Prasad, working as an assistant professor in the Department of Electronics and Communication Engineering of KPR Institute of Engineering and Technology. In today's session, we are going to discuss CMOS static and dynamic logic. So these are the content today we are going to discuss. The first we are going to discuss the summary of previous session, and followed by we are going to discuss the overall classification of an CMOS logic, and out of CMOS logic we focused only three different type of logic, which is called to be an static, dynamic and ratio logic. So this is just in a summary of previous session what we have discussed. So in previous session we have discussed the basic principle of CMOS transistor and the effect of NMOS transistor and PMOS transistor when it is connected in series and parallel. So this is short summary. When NMOS transistor connected in series, it acts as an AND function, and when it is connected in parallel, it will be act as an OR gate. I mean some terms. Likewise, PMOS transistor, when it is connected in series, it will be act as an OR function. When PMOS transistor connected in parallel, it will be producing of NAND function. So this is the summary we discussed, what we discussed in the previous session. In this continuation, and how that series and parallel combination of series and parallel combination of NMOS and transistor and PMOS transistor, it will be helping us to implementation of different combination logic circuit. So this is overall classification of CMOS combination logic circuit, and actually I have listed more than 7 or 8 types of an CMOS combination logic classification, and out of this 8 classification we focused only static, ratio and dynamic circuits. So first let me explain what is static CMOS logic. So basically static CMOS logic is consist of array of pull-up device and array of pull-down devices. So basically pull-up transistor will be array of PMOS transistor, and for pull-down transistor will be NMOS transistor. The question is, in static CMOS logic, why I placed PMOS array to VDD, why I placed NMOS transistor to VSS. So this is the justification already I given in my previous lecture session. So why PMOS transistor is connected to VDD is PMOS transistor need of maximum voltage, since positive ions will be dominating of negative ions, whereas in NMOS transistor it consists of maximum number of negative ions, and the negative ions will be dominating of positive ions. So that's why NMOS transistor will be connected to VSS. And in static CMOS logic, the pull-up device will be connected between VDD and output, and NMOS transistor will be, pull-down transistor will be connected between output into VSS. So basically in static CMOS logic, at the junction of PMOS transistor and NMOS transistor, we are going to taking the output. And one more thing, for designing of static CMOS logic, we need of 2 to the power 2 into n number of transistor, where n number of PMOS transistor and n number of NMOS transistor. So for example, so let me take an example expression, y equal to a dot b plus c the whole complement. So we are in the position to implement the given combination logic circuit using static CMOS logic. So the given expression is a combination of both series and parallel combination. So we discussed in previous slide, for static CMOS logic, an n number of PMOS array and n number of NMOS array. Okay, so the given function comprises of, the given expression comprises of 3 inputs. So we need to be use 6 number of transistor, in which 3 for PMOS transistor and 3 for NMOS transistor. So either we can remember NMOS rule or PMOS rule. So this is summary we discussed. When for product term implemented through for NMOS transistor, product term will be implemented through by series connection. For implementing of OR function, we need to be connect NMOS transistor will be parallel connection. So the given expression is consist of a dot of b plus c. So it consists of b plus c one OR term. So when I placing of NMOS transistor, I need to be connect B plus for B and C input. The transistor should be connected in parallel. It is associated with a product term A dot. So the input A will be the parallel combination of B plus C. It should be connected series with input A. So this is all about for pull down network. For pull up network will be just in reverse operation. For implementing of B plus C through PMOS transistor, both should be connected in series and it is connected parallel with the other input. It is called to be A. So this is the structure. As I said, for pull down network, it comprises of B plus C. It's in a product, sorry, it is in a sum term. So NMOS transistor are connected in parallel and associated with A dot is connected with series. So this is the combination of N1, N2, N3, which is called to be an NMOS array. The combination of P1, P2, P3, it form an pull-up transistor, PMOS array. The junction for NMOS transistor and PMOS transistor, we are going to get an output. The next is the second type of logic is a ratio logic. So the first difference compared to static CMOS logic, like in static CMOS logic, it consists of n number of PMOS transistor and n number of NMOS transistor. Whereas in whereas in ratio logic, the pull-up device is always connected. So that is why in graphical representation of ratio logic, instead of pull-up transistor, I put the circuit comprises of load. That load is always connected. So since load will be always connected, the VDD, the output voltage across the output voltage at end F will be always equal to VDD, and based on the input that we are going to connect it for pull down network, the output it may be stay at the same VDD level or it may be goes to be a ground level. So this is what basic principle of a ratio logic. So the first advantage compared to static CMOS logic, the ratio logic, since it consists of only one pull-up device, that is load, the number of transistor compared to static CMOS logic will be is less for implementation of same combination function. So here are the two different types of ratio logic. It is called to be a pseudo NMOS logic, and second one will be depletion type NMOS transistor. So when we compare the both representation like a pseudo NMOS logic, depletion type NMOS transistor, like a pull-up device will be on condition. So this is what basic principle of a ratio logic. Like in pseudo NMOS logic, the pull-up device is called to be a single PMOS transistor. The single PMOS transistor control terminal, I mean gate terminal, is connected to ground. So PMOS transistor is always on connection. So the output, since the PMOS load will be always on connection, the VDD level will be stored across the capacitor at node F. The output VDD, it may be stay at VDD level or it may be in a ground level. So based on the input that you have connected for pull down network. Whereas in depletion type NMOS transistor, the pull-up device will be type of load is called to be a depletion load. So just remember the basic difference between enhancement and depletion type transistor is, for enhancement type transistor, when VGS equal to greater than or equal, when VGS equal to 0, the transistor is an off condition. Whereas in depletion type transistor, when gate to source voltage equal to 0 volt itself, the transistor become an on condition. It means the channel will be depleted from source terminal to drain terminal. So in depletion type NMOS logic, the depletion transistor, both gate and source terminal will be short circuit. So VGS equal to 0 volt. So the depletion type transistor is always on connection. So at any instant of time, the output will be at the voltage level at node F will be VDD. That VDD voltage will be stay at the same VDD level or it may be goes to be on ground level according to the number of transistors we are going to connect in pull down network according to the external input that you have connected for pull down network. So this is a simple example for ratio logic. The question is consider a 4 input NOR circuit, NOR logic circuit and NAND logic circuit using pseudo NMOS logic circuit. So just remember for pseudo NMOS logic, so the type of pull-up device will be PMOS load and it consists of pull down network n number of NMOS transistor. So the number of transistor we need to be placed in pull down network according to the number of inputs. So here we have 4 inputs A, B, C, D. So I need to be, since it is in a pseudo NMOS logic, the pull-up device will be PMOS transistor, single PMOS transistor, and gate terminal will be connected to ground. Whereas in pull-down network, I need to be placed 4 number of NMOS transistors, since it consists of 4 inputs. So all 4 input, it is associated with product term A dot, B dot, C dot, D. So all the 4 input, for all the 4 transistors should be connected in series. The junction of PMOS transistor and NMOS transistor, we are going to take an output. So this is what the structure of pseudo NMOS logic for 4 input NAND gate. As I said, it consists of 4 inputs. So I need to be place 4 transistors in the place of NMOS transistor, NMOS array. Since it is associated with a product term, 4 transistors should be connected in series, and 1 PMOS transistor will be act as a pull-up device. And for NOR gate, again, for NMOS logic, I need to be place 4 number of transistor, since it consists of 4 number of input. Since all the 4 input associated with some term, I need to be connect all the 4 input will be in parallel combination. So I need to be placed single PMOS transistor in the end of pull-up transistor. So the junction of NMOS transistor and PMOS transistor, we are going to take an output. So next, the third type is called to be a dynamic logic. So the first observation compared to static and static CMOS logic, like in static CMOS logic, is consist of n number of PMOS transistor array and n number of NMOS transistor array. Whereas in dynamic logic, single PMOS transistor and single NMOS transistor will be working based on pre-charge and evaluation based. Correct? Like in dynamic logic, both the transistor MP and MP it indicate to be a PMOS transistor, ME it indicate to be a pull down transistor. Both will be triggered by clock pulse. So that is why dynamic logic, it is also called to be a clocked CMOS logic. So what is the basic principle of dynamic CMOS logic is, it is works based on pre-charge and evaluation. So what do you mean by a pre-charge means? The pre-charge means only PMOS transistor is connected, and whereas in a evaluation phase, according to the external number of input you have connected for NMOS logic, the output will be evaluated. It will be evaluated to VDD level, or it may be evaluated to 0 level. This is according to input what we have connected for NMOS logic. So first let me explain you what is pre-charge operation. Like in pre-charge operation is happening during clock 0 time interval. When clock input will be 0, only PMOS transistor is connected and the NMOS transistor ME will be disconnected. Since PMOS transistor is connected, the VDD level will be through transistor MPP. It is stored across the capacitor CL. So the output will be stay at VDD level. And when evaluation phase is started, evaluation phase means it is happened during logic 1 time interval of clock signal. When evaluation phase is started, based on the input that you have connected for pull down network, NMOS logic, according to the number of transistors become an on or off condition, the output may be stay at VDD level, or it may be goes to a ground connection. If path is exist between V out to ground level, it output will be goes to be a 0. If no path is exist between V out to ground, means the output will be stay at VDD level. So what I am trying to say is, according to the number of input we have connected for pull down network, the pre-charge level VDD will be stay at same level, or it maybe goes to be a ground level. So this is what the basic principle of a dynamic CMOS logic. So let me explain you a simple example. For example, let me take an expression y equal to a dot b plus c the whole complement. In dynamic CMOS logic, I need to be placed single PMOS transistor for pull-up operation and one NMOS transistor for pull-down network. Okay, so between this pull-up network, between this pre-charge operation and evaluation operation, I need to be connect n number of transistor in the place of pull-down network. Okay, so it comprises of The expressions consist of 3 input, so I need to be placed 3 NMOS transistors in the position of NMOS logic. So how I need to be connect series or parallel combination. Okay, according to the given expression A dot B. So I need, since it is in a product term, A dot B should be connected as in a series, and this series combination will be having parallel combination with input C. So this is what the dynamic CMOS logic structure for given expression y equal to A dot B plus C. So associated with 3 input, so in the position of NMOS logic, I need to be placed 3 transistor in which A dot B a connected series and C will be associated with parallel combination. So the junction of pull up transistor and pull down network we are going to taking up out. So next we are going to discuss 3 important drawback of dynamic CMOS logic. The first drawback what it says is, when 2 dynamic logic connected in cascade form, the output will be goes to be a wrong state. So for example, let me take dynamic logic 1 and dynamic logic 2. Both are connected in cascade form. So cascade form means when you are going to connect n number of devices, the output of first device will be act as an input for second device output will be act as an input for third device. This is called to be a cascade connection. So here I am taking of 2 dynamic logic 1 and logic 2, both are connected in cascade form. So why it is connected as a cascade form is the output of dynamic CMOS logic 1 will be act as an one input for second dynamic CMOS logic. Okay. So what happened? Kindly look at, this is the waveform. Kindly look at the right hand side, the timing waveform. Initially in dynamic CMOS logic, the first we are going to consider for pre-charge operation. So the pre-charge operation will be happen during logic 0 time interval. So what happened during pre-charge operation is, both PMOS transistor of dynamic logic 1, dynamic logic 2 will be both are connected. So V out 1 will stay at 5 volt, V out will be stay at 1, and V out 2 also output V out 2 also stay at VDD level. Then based on the external, so what happened in dynamic logic is, so basically in speaking practically, after evaluation phase is completing of first stage only, the output of first stage will be connected to input of second stage. But in dynamic logic what happened is, once the pre-charge operation is completed, before completing evaluation phase of first stage, the output will be connected to input of second stage. So this is called to be a wrong concept. So why it is? For example, I am taking actually during pre-charge operation, for V out 1 will be stay at VDD level, V out 2 will be stay at VDD level. Both will be 1. V out 1 actually, for example, in first stage NMOS transistor, for example, it consists of, in first stage NMOS logic, for example, I put in one NMOS transistor, the external input signal will be 1. I mean the path will be exist from V out to VSS. So when evaluation phase is started, the pull down NMOS transistor become an on connection. So first stage of NMOS logic consists of only single NMOS transistor, external input will be 1. So the NMOS transistor which is incorporated in first stage NMOS logic, it is also on condition. So V out supposed to be 0. Since V output supposed to be 0, in second stage of NMOS logic, the first NMOS transistor will be become an off connection. So V out 2 will be supposed to be stay at VDD level. V out 2 will be supposed to be stay at VDD level. So this is what correct statement. But what happened in dynamic logic is, before the first evaluation phase of first stage is completed, instead of connecting of 0 input, the pre-charge output 1 will be connected to input of second stage of NMOS logic. So what happened is, in second CMOS, both NMOS transistor and NMOS logic will be connected. So output goes to be an 0. So this is called to be an error state. Okay. So how it will be overcome is by placing a known delay between dynamic logic 1 and logic 2. So we need to be, this is called to be a static inverter. Here we need to be define the standard delay unit. That delay unit will be comprising the output of first stage to input of second stage. And the second drawback is charge sharing. So for example, so the first VDD to VSS level, it is called to be in a dynamic logic. So for example, the output of dynamic logic, I mean at node Vx, input voltage will be connected to input for an inverter circuit. During pre-charge operations happen, only transistor P1 will be connected, N1 will be disconnected. So the output on the node voltage at Vx is equal to VDD, approximately equal to VDD. It is 4.7 to 5 volt. I called it a strong logic 1 signal. Okay. When evaluation phase is started, so like in NMOS logic array is consist of only one transistor, N2 transistor. The input for N2 transistor will be logic 1 input signal. So it means that the N2 transistor during evaluation phase started become an on condition. So before evaluation phase is started, the node voltage will be 5 volt. Node voltage will be 5 volt. The voltage drop across the capacitor C1 will be 5 volt. When evaluation phase is started, since N2 transistor is connected, the charge sharing problem will be taken place between the capacitor C1 to C2. So since the N2 transistor is connected, out of 5 volt, for example, 0.3 or 0.4 voltage will be discharged through capacitor from C1 to C2. So what happened is, since that no path is exist between V out to VSS, logic 5 volts, I mean logic 1, it is supposed to be connected for input of an inverter. But what happened is, during evaluation phase is started, since N2 transistor became an on condition, instead of connecting of strong logic 1 signal, weak logic 1 signal will be connected to input of inverter circuit. So this has happened due to charge sharing problem between the capacitors C1 and C2. So how this problem will be rectified is, the same structure, here I am going to placing up one extra transistor which is called to be a weak pull-up transistor. That weak pull-up transistor is the responsible, it will be controlling of charge sharing between transistor, it will be controlling of charge sharing between capacitor C1 and C2. Thank you.